Hey, welcome to another training video. We are focusing again in Conversational CAM Pro on a very specific spiraling toolpath called Spiral Threads. And so we're going to answer again two questions just like other basic toolpath videos is what does this process do to the part? Okay, what's the final result of what this cutter does? And how do I control it? How do we program it here in CCAM Pro in order to give us that result? And we're going to answer that question here in this video. So we're going to visualize that in both the Aspire software as a 2D drawing, as well as going to the machine afterwards and cutting the part so you can see all this take place. So let's jump on over to our Aspire software. And we're going to have a blank here that is, in this case, we don't need a super long threading sample like we've done in the other videos. So this one is a 9-inch diameter blank. And I have a square section here at the beginning. And then we have a turned round section here for the rest of this process, okay? Now the turning round process has already been done. So that takes the surfacing cutter and it starts at this position and it travels down that material until it gets to the end and then lifts out. And I've already done that on the machine. And if you haven't seen the video that shows how to program a turning round process, definitely go check that out. In this video, the threading process, we're going to be using specifically a V cutter, okay? And this is going to come to the surface of the part and it's going to plunge down a certain depth based on the thread parameters that we're going to be determining. It's going to also travel down the stock as it's rotating. And then when it gets to the end, it's going to lift up out of the material just like any other spiraling toolpath. The difference from this spiraling toolpath versus the others is that the barley, the rope twist, the hollow spiral, all those other twist factors, those are all for aesthetics. It's just visually pleasing to add those designs to your spindles. Whereas wooden threads is not really for looks. It's more for functionality. Okay, it's because you want to add this function to your project of being able to have a mechanical thread embedded into that project itself. Okay, so if I want to add some threads, let's help again visualize what these could look like. And again, this doesn't have to be drawn in this manner in order to program it, but it helps visualize it. So let's center that. There we go. And there we have what the V cutter is going to do. Okay, it's going to plunge and then again spiral all the way down, creating us this wooden thread effect. So let's show how we can program this right in CCAM Pro, okay? Because we have a couple of variables that we can control in order to give us whatever thread size we wish. So if we go to CCAM Pro here, we're going to go back to our project and our training sample project that we've been using throughout these videos. I'm going to go to my workstation, and if we click on this part, we're going to have our toolpaths that have already been laid out, but we're going to go add another toolpath. So let's go to Manage Toolpaths. And again, we've already programmed the turning round process to take place on this, you could say, bolt, this wooden bolt that we're going to be producing. So let's add the last spiral process on our list, and that is the threads. Okay, spiral threads and add. Okay, and we can close that and let's go see what the questions are for the threading process. We'll click on here, and the first thing it does is what tool do we need to use? Now, typically, a majority of the time, you're going to be using a tool that matches whatever angle is in this field. So you can choose two different angles or the most common type. For example, metal threads and plastic threads typically have a 60-degree thread. Okay. However, in wood, if we look at the design, okay, in wood, all of this, the grain is going from left to right. And so these corners and sharp points, you run into a risk of those chipping and tearing out the sharper this point is. So normally we don't use a 60-degree V cutter in wooden threads, even though you can if you wish. There are different types of threads that you can apply here. This one, we're going to apply a 90-degree thread. Okay, so it gives us a little bit more stability in the shape of the thread based on the material that we're using for wood. And so here I'm going to put the tool angle was defaulted at 90. So I'm going to make sure that the cutter that I'm selecting is for a 90-degree V cutter. So if I go to V bits here, and we have a 90-degree 1-inch diameter tool that we're going to be using. okay? And that will be tool number 2. All right, now the next parameters is just like any other spiral. It's like, where does it start? Where does it end? Well, let's go quickly grab those. And so we can go to our dimensioning tool here. And from a horizontal dimension on the left side, this is X0. We want to start at the center of that cutter right there, okay? So that's at 3 inches is where that thread starts. And then if we measure all the way here, all the way to the end, center of the cutter all the way to the end, that is an ending position of 9. So 3 and 9 will be our start and ending points. So let's put that in here. Start 3, end 9. And now we need to know the section diameter that this thread is being turned onto. And so if we come over here back to our dimensioning tool and we click on vertical dimension, this whole section diameter is turned round to 2.5 inches, just like the other demonstrations. Okay, so if we go back, we're going to put a section diameter of 2.5 inches. That's the diameter section that this thread process is being applied to. And now here is where we get to now create some custom data based on how many threads we want to have per inch. Now if we look, this has already been drawn a certain way to show you how many threads per inch this would be. If we were to measure, okay, just a horizontal dimension, let's say from the top of this thread and I go over 1, 2, 3, 4, I should have this be a 1 inch length. That's exactly right. So I drew this out as a 1, 2, 3, 4 threads per inch is how this is laid out. That means that each thread, okay, this is the number that we're paying attention to. So 4 is the magic number that I'm going to put into that field based on what the results are that I have here on my drawing. And so here, threads per inch, I would put in 4. But we can also see the individual thread size, and you can work that way as well. So if we do a dimension and just measure from the top of the thread, and that equals 1/4 of an inch. Well, how many times can 1/4 of an inch go into 1 inch? Well, it can go into 1 inch 4 times, so we'd have 4 threads per inch, okay? So there's different methods of finding that information. You can do it by measuring a full 1 inch, or just measure the thread and see how many of those actually go into 1 inch itself. So we can make our thread count per inch anything we want. We have full control of what that looks like and what it's going to be. And that will automatically calculate the cut depth of the V cutter to accommodate again, how many threads per inch are taking place. So here we don't have to put in a cut depth. It's automatically going to happen. Okay, we also get to choose. Do we want the thread to rotate to the right or to the left? Traditional threads are rotating to the right. This question here is saying, do you want to terminate the threads? Is defaulted as yes. Think of it as that at the beginning of the threads, it's going to do a turning tool profile of the V cutter all the way around the circumference. That's what this line represents. Okay, that vertical straight line right there. Okay, that's just a termination process at rotating the cutter around the circumference before it starts the actual spiraling process itself. Okay, so that is a termination, and that's defaulted as yes. It's just going to implement that automatically into the system. We don't have to worry about it. And the rest of these parameters are already filled in. Again, just how fast it's cutting and additional clearances. So all we had to do is choose a cutter, start and ending position, how many threads per inch we want to perform, and we're done. We can now go to finish and save, and let's generate our G code. So here, we're not going to save both of these out to one program because we've already turned the stock round on the machine. So we're just going to save out the threads, spiral threads themselves. So let's go generate the G code. And that's for, again, a 90-degree V cutter is going to perform the threading process in that short amount of code. So let's save out this G code. And we're going to put this in Toolpaths, where we're doing all of our demonstrations. And we have, let's see, spiral threads. And this will be the spiral thread G code. And save. So now let's go to the machine and see this process take place. To begin, the cutter comes all the way down to that section diameter of 2.5 inches to start a controlled plunge into the material while rotating the stock. This is going to be doing that termination default, where again, it turns the profile of this cutter around the circumference of the part before it starts the actual threading process. Once it's applied that 360 degrees around the circumference, the cutter immediately starts traveling down the length of the stock, and it's traveling 1/4 inch per rotation. That's 1/4 inch pitch, giving us 4 threads per inch. The cut depth was automatically calculated, but with a 90-degree V cutter, this is actually cutting 1/8 inch deep into the material. Now, the cutting speed is not very fast for this process. That's because all the cutting taking place is actually cross-grain cuts. And because the threads come to very sharp points around the entire process, we want to minimize that tear out that could take place around these wooden threads. All the cutting advantages shown here are automatically implemented into CCAM Pro. The reason we chose 4 threads per inch is to match the internal threads of this wooden component. You should now have a basic understanding of how to use the Spiral Thread Toolpath and what it does to the material. Why don't you go out and try it yourself? Now, these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.